So now incentives, like I mentioned before, incentives are used to increase profitability of the entire supply chain. Sometimes you want to share the risk between all the parties so that the supplier is incentivized to produce more and the buyer is incentivized to buy more. And as I said, sometimes you may have excess product, but the profitability is still higher. It may not be optimized, because optimized basically means that you've maximized your profitability, but you will make more profit than if you just stuck to a suboptimal scenario. So there's four main types that they talk about in the book. So we've got buyback contracts, revenue sharing, quantity flexibility, and sales rebates. There's a lot of them in there, actually. There's quite a few, but these are the main big ones. Because one of the assignments, and this is a very difficult assignment, I think it's like week 7. It's a very complicated assignment where you're going to basically calculate all this stuff, and they're going to say, okay, create an incentive. How would you incentivize this, and calculate how this incentive would change the profitability? There's a lot of math involved, so be forewarned. I think it's week 7 where you're going to have a lot of work going on. So, and I may have a special video conference for that one, because that one students traditionally have a lot of problems with. But so incentives, buyback contracts. It's very simple. The supplier offers to pay the buyer for unsold units. So the supplier may say, hey, look, in the previous scenario where the buyer buys 900, but the supplier wants them to buy 1,000, then they'll say, hey, look, buy 1,000, and for any ones that you do not sell, we will buy them back from you for a certain cost above salvage cost. So let's say that the salvage cost is $10. They'll say, look, for any products that you cannot sell up to 1,000, we will pay you $11 for each one. So now, and what you're going to find out with these calculations is you basically shift profit from the supplier to the buyer up to that 900 point. Now, obviously, if the buyer is able to sell all 1,000, everyone makes a lot of money. But what you do is just say, hey, look, if you're not able to sell everything that you buy from us, we will shift some of our profit to you to offset some of your risk. And so when this happens, the buyer is incentivized to buy more units. So because their profitability model basically will shift a little bit, so that now they may be able to, ideally, if it's calculated correctly, the incentive will be up to 1,000 units. In a real world, it rarely gets to the full, to the full point, because obviously the manufacturer starts to lose profitability and they begin to assume more and more risk. So there's a point where the manufacturer is not going to be willing to have that much risk to the profitability. Although in a theory of constraints strategy, if they're at that point where the fixed costs are absorbed, they may do something like this because, okay, fine, if the salvage cost is, say, $1.50, and we're at $1, we're not going to lose much profitability. So this is a way for the manufacturer to help shift some of the burden. So and this is typically used in make-to-order contracts. You could use this in a make-to-stock contract. It's theoretically possible. I haven't seen it that much in make-to-stock contracts. Now, to be fair, I haven't seen this a lot, but I guess theoretically it is possible. So revenue sharing contract is the opposite. The buyer shares revenue with the supplier in exchange for a discount. So the buyer, let's say in the previous example, the buyer expects demand to go up to 1,200. They'll say, hey, look, supplier, build 1,200, go above the 1,000 that you're contractually obligated, go up to 1,200. And in exchange for you to go up to 1,200, we will give you extra we will pay you more for each product. Okay. Or what they'll also say, in this regard, they'll go, we want to go up to 1,200. Give us, charge us less money per unit on these extra 200 so that we could provide an incentive for people to buy this product. And in exchange, we will share the revenue for any product above the 900 that we're obligated to buy. Does this make sense?
Yes.
Okay. Now, once again, like I mentioned before, when you do this, you have a chance of artificially inflating your demand and shifting your demand. Because what I've usually seen with this is, let's say your demand, you sell all 200. Well, actually all 300. You went from 900 to 1,200. Well, what part of that 300 are new customers? What part of those 300 are customers that bought early? It's hard to tell. It takes time for you to get enough demand forecasting in to be able to understand the new demand shift. But unfortunately, a lot of these decisions are made inside that scope. So it's not too uncommon to see this type of incentive result in erroneous demand forecasting going forward. It takes time to adjust.
But to that point, based on technology today, and I'm going to throw my technology hat on, and business intelligence, BI, and big data. So when you start analyzing, okay, who's a net new customer versus who is a current or even an upsell customer, that's where you can ascertain that that type of demand. If a company has those types of capabilities with the systems that they have through CRM
Sure. And a lot of the benefits of CRM, it's able to do this not because it can read the mind of the consumer, but because the data is so instantaneous that they could detect these demand changes. And with certain algorithms, they can say, okay, based upon how demand changed since we did X, we have Y number of new customers, because these CRM algorithm models have that built into it. But once again, as I always say, models are only as good as constraints that are designed into them. The CRM models are actually very good nowadays. They're not perfect, but yeah, you're right though. The business intelligence has gotten much better, but I have seen many instances where there's too much reliance on the data. Like case in point, when the market crashed, the market crashed because all these buy and sell algorithms basically said to buy and sell at the same time. Now, is the CRM systems that are used by VMIs better than the old-fashioned way? Oh, of course, much better. All I'm saying is that human behavior is a little bit more random sometimes, and the models can portray. But for, like you said, like 99% of the time, yeah, these models are pretty accurate. Okay. Now, quantity flexibility contracts. This may not be in the textbook, but basically, the supplier provides a full refund for unsold products up to a certain refund level. Okay. So the overstock costs are shifted to the supplier. So they say, look, we're going to build 1,200. You will buy 1,200, but we will provide a refund for any products up to 900 that you purchase. So go ahead and buy 1,200, and if you sell 1,100, great. We'll buy back that 100. Okay. If you only sell 900, we'll buy back those 300. At the cost that you paid for the products from us. So what this does is it's very effective for shifting the risk from the buyer to the supplier. up to the refund level. Okay, so this encourages the buyer to encourage purchases to this encourages buyers to purchase units up to whatever the refund level is. So up to 1,200 units, we will refund you whatever you don't sell. Okay. Obviously, this is a very risky proposition for manufacturers, so they obviously don't do this very often. But it's something that they can do if they foresee, or they may do this anyway if they're in that area of constraints area where they've met all their fixed costs. They may say, hey, look, yeah, we have a new buyer. We can offer this because our risk is very low to begin with. So,
and they could have secondary markets that they could sell them to without going down to salvage costs.
Sure, and sometimes, like in this example, if the salvage cost is more than, like in the example where the variable cost per unit is $1 and they're selling it for 10, as long as the salvage cost is over $1, they're still making money.
Mm-hmm.
Now, obviously, you want to sell those in different markets. You don't dilute, because if you start to salvage these items in the same market as your buyers, they're going to get a little pissed off at you.
Of course.
But you understand the basic concepts.
Mm-hmm.
So, now sales rebate, and this is the last. I think this last one that I cover, maybe. Oh, okay, yeah, this is sales rebate. Basically, provides a rebate to retail for any units sold over a certain quantity. This is the general rebate strategy. So the supplier says, "Hey, look, we have a whole bunch. If you can, for any units sold over a certain amount, we'll provide a rebate." And you know how the rebates work. We had a very lengthy discussion in the discussion questions about how rebates work. And and this is a way for a company to mitigate risk by basically, it's kind of like a shell game. Like you said, we're going to offer rebates to increase demand. If the customer takes advantage of the rebate, fine, we still make money. If the customer buys a product and doesn't take advantage of the rebate, we make more money. And this is, like it says here, typically used by the supplier to sell overstocked units. So this is when the supplier goes, wow, we got a lot of stuff here. We're going to go to all our buyers. And this is where the distributors come in. They say, hey, look, we got other, manufacturers with a lot of product. They may see one of their buyers just begging for stock because they may be in an area where there's a high demand. They'll say, hey, look, we're going to offer a rebate to you because the manufacturer is offering a rebate to us to get rid of products. So that's a way to shift, to shift the risk over from a manufacturer who may not have access to a certain market to a new buyer. So this is pretty direct. We've talked about rebates at length. So these are 4 incentives. I think there's quite a few in the textbook, but these are the main ones. Any questions?